Hello. Before we get started, just a quick note that we will be recording this session for future reference. You can watch it again on demand on the Wiley Science Solutions website, sciencesolutions.wiley.com, on the webinar page. Hello, my name is Mark Lucchetti, Field Marketing Manager with Wiley Science Solutions. It is my pleasure today to introduce you to our speaker, Editor of Software Products, Calvin Stevenson of Wiley Science Solutions. Calvin is an accomplished editor at Wiley and specializes in spectral solutions and new technologies. He holds a postgraduate degree in data analytics from George Brown University and has a Bachelor of Technology in Biotechnology from McMaster University. We are excited to have Calvin present us today his webinar entitled Latest Advances in Spectral Identification, SmartSpectra, Classification Models, and More. We encourage the audience to submit questions which will be addressed at the end of the session. With that, I'll turn the session over to Calvin for his presentation. Take it away, Calvin.
Thank you for that introduction. In this presentation, I will be exploring the latest advances in spectral identification, specifically SmartSpectra, classification models, and analyze it within the KnowItAll software. Comparing and matching unknown spectra to known spectra is one of the most effective methods for spectral identification. The typical flow is that your sample is run through your instrument, producing a spectrum representing the sample. This is then imported into specialized software to match known spectra in digitized databases. This is all pretty easy, but what happens when you can't find a strong match, or if you can't find a match at all? This is where we've come up with a few alternative strategies to approach this problem. These different approaches would either identify, classify, or characterize the data. Our first option is Wiley SmartSpectra databases, which can be searched on, classification models, and functional group analysis using Analyze It, a tool within KnowItAll software. But what is KnowItAll? KnowItAll is a software solution that gives you tools to identify, analyze, and manage your analytical data for the purpose of increasing lab efficiency. KnowItAll is designed to work as you do, so you can move seamlessly from task to task without having to leave the interface. The power of KnowItAll software is how versatile it is. KnowItAll eliminates the need for multiple software packages because it's compatible with so many different chemical techniques. It also having a single software solution for all the instruments in a lab cuts down significantly on the training needs of lab personnel. As you can see, it works with IR, Raman, GCMS, LCMS, NMR, and UV-Vis, and has a wide range of compounds and applications. KnowItAll has automated algorithms in the spectral search process, such as optimized corrections and adaptive search, that increase the chance you receive a match with your uploaded spectrum. Wiley also has the largest selection of digitized spectral data available, increasing the chance you get a match further. So we come to our first alternative route to identify, characterize, or classify an unknown. This is the SmartSpectra databases. These databases can impact your workflow by increasing efficiency with unknown identification and characterization, as I mentioned. They expand the chemical compound coverage for faster analysis, and they are derived from trustworthy, high-quality empirical data. The final results were tested and validated by subject matter experts. So here we have an example of the increased chemical compound coverage. This is a chemical space visualization showing how much more chemical space we can cover with SmartSpectra. The graphics points, blue or red, are essentially a 3D dimensionally flattened chemical structure. They are grouped by structural similarity. Note that there is less white space between the points in the second image with the SmartSpectra added, as it is the red dots, and we will show this in a more zoomed image in the next slide. This will help illuminate the difference. So on the left, you have both SmartSpectra and empirical data overlaid. And then on the right, you can see the two images with the zoom to 130%, and one with empirical and one with the SmartSpectra included. The zoomed images show the increased density of the compounds covered in our catalog, as there is a lot less white space. Also note that the SmartSpectra records do not exceed the structural boundaries of our current catalog. As you can see, the blue empirical data sets a hard boundary for the red SmartSpectra data to stay inside, and it does follow this rule pretty well. So this will go over the validation and usage recommendations. So the SmartSpectra model was trained on Wiley Science Solutions high-quality data collection. We conducted validation studies to ensure we were producing strong results that work. And our subject matter experts also looked at these studies and the SmartSpectra themselves, concluding that SmartSpectra performs well with spectral searching. The optimal workflow is to employ SmartSpectra if there are no high-quality hits or if the hits are low quality with the empirical data, and then to use the SmartSpectra after that. This reinforces that empirical data is still and always will be the industry standard, and we will never waver in this statement. So we have a few collections available. For IR, we have over 250,000 spectra. For vapor phase IR, we have over 215,000 spectra. And for Raman, we have 33,000 spectra. There are no replicates in any of these libraries, as in all the compounds in each technique are unique. So this brings us to our second alternative method of classification models. Our classification models are another layer of added support for unknown identification. You can classify spectra when it cannot be accurately identified with spectral searching. These models can be used to confirm or validate results as well. And the models are easily integrated and can be run quickly as a first pass method or as a confirmation of a spectral characterization. Since the models are locally installed, they are extremely quick and do not require a connection to the internet. The classification models were cross-validated multiple times in testing to ensure that they work correctly, and their current coverage is key drug categories. In the future, we may look to expand and include some different classifications as well. So these are the current models. All three techniques we currently support are IR, GCMS, and Raman. And all of these models have over 99% accuracy. And do note that the IR, GCMS, and Raman do have different models. They are not all the same. And so this is an example of what it would look like in ID Expert, which has a classifications tab built into the interface and runs in the background. If there's a hit, it will flash quickly. And I'll show this in the demo later. And this is the interface in MineIt. And it shows the results from running all the models in batch on 3 different techniques, in this case also 3 different records in one database. We also offer more automation with the KnowItAll software development kit if that is required. And this brings us to our final tool, which is functional group analysis. Functional group analysis with KnowItAll is in KnowItAll. And KnowItAll is included in the analytical edition of KnowItAll. KnowItAll uses peak picking to match typical peaks by region and intensity, which can be saved or compared against knowledge bases. It is an excellent final self-directed tool in the process of unknown characterization. It can be used in conjunction with the other tools to augment the characterization of unknowns. The results from this self-directed process can be included in a report generated right in KnowItAll as well. And so these are the current KnowItAll knowledge bases. As you can see, the knowledge bases are different based on the techniques. The techniques available are organic IR, polymer IR, vapor phase IR, and Raman. As you can see, the vapor phase IR is quite specific to synthetic cannabinoids, whereas the other ones are a bit more general. Users can create their own knowledge bases though, and creating your own custom knowledge bases tailored to your own data can obviously help you if you're in a very niche or specific field. And so now, with all this information, let's take a quick look at KnowItAll and do a demo for the 3 methods of alternative spectral identification or characterization. So, this may be your first look at KnowItAll, and before the demo, I will do a brief introduction. So in our basics, we have Chem window, report it, and browse it. Chem window is for basic structure work. I'll show this a little bit later. In our data tab, we have the meat of KnowItAll. So here we have ID expert for quick identification, search it for spectral searching, and mine it for database work. In the processing tab, we have LC and MS expert along with process it. And this is for spectral processing and editing. In spectral analysis, we have analyze it, which was our functional group analysis tool, and predict it NMR, where you can predict NMR spectra. And then below that, we have our quantitation tool. And so we will start with search it. But first, I will import the structure that we're going to be searching for, just so that you're aware of what the end goal is supposed to be. So I'm going to open here. I'm going to go back to and this is the structure file we're going to use. Okay, so this is our end goal for the search. And so this is an example where an unknown gets a better match with additional SmartSpectra libraries. So we'll start by adding in our spectrum that we're trying to search. And note here we're using all compounds, which is empirical data only, as the use computed spectra, which is the SmartSpectra databases, is not checked off. And so we will search. Takes a second. And our top hit is pretty good. Actually, our top few hits are pretty good. And they would be good for characterizing what the unknown is. As you can see, if we go back to Chem window, this is what it looks like. So it's a little different. So say we weren't happy with this, we wanted to get a better result. So then we would X out of this here. Actually, we'll keep it. So we'll go back to search it, and we'll do use computed spectra. And so this enables the SmartSpectra databases. Okay, and this is also following the prescribed method of where we try empirical and then go and try a SmartSpectra search after that. And so this is a search with the SmartSpectra included. Takes a bit more time because there's more records to sift through. And we actually get top hit. And if you look at the structure, I believe it is an exact match for what our search structure was. So in this case, it worked out pretty good. And search it without, and so we'll move on from here. But obviously you can see the search it is a pretty good tool in case you want to move and get a better result. All right. Now we will move to see how the classification models work as a second alternative strategy. So I will go to ID expert, now open. So for example, I'll show you what happens if there are no classifications for a spectrum. So I'll open this one. I can even fix contaminants. And as you can see, this classification is already done, and there weren't any hits for it. So this is what it would look like if you didn't get any hits for something. In this case, it is correct. This isn't classified by, this isn't a drug, so it's not going to be classified by any of our models. Okay, so let's try something correctly. So we will move to PC, C, users, public, documents, Wiley, KnowItAll. And then we'll go down to samples. And in samples, in computed spectra, we can do a IR sample. Let's try this one here. And the classification is already done, and it's a general and natural opioid. So this was oxycodone, so this is correct. And see how quick it was. And then if we go to our results, oxycodone is the first result as well. Okay. And so let's try it in batch. So if I go to mine it, and I go to open from browsing, and here I have the demo database. And here we have an opioid, steroid, and a steroid. And so what we're going to do is go to database, batch property calculation. And then here I have classifications for IR, GCMS, and Raman. I have it on all. You could choose a selection or current, which is your current record that you have highlighted. But I'm going to do all in this case. I'm going to hit next. It's done pretty fast. And then what I'm going to do is I'm going to add some columns to the display. Okay. And then I'm going to move the structure down just so it looks a little better. All right. And as you can see, it correctly classified the opioids. It has its own property window, and it has all the property windows are specific to each of their own techniques. And then another cool feature is that you can do transfer it. So say you had a larger database and you just wanted to see what it was. You didn't want to run it on the whole thing. You can use transfer to and send it to ID expert. As you can see, the classification is already done and it has 100% score, which is also correct, as we see here in the search. So a pretty nice little tool there. Okay, so after this, we will jump to analyze it, which is down in the spectral analysis box there. And so in analyze it, our third alternate strategy for unknown identification, you can either choose a spectrum or a structure. I will start with a structure. So if I go here, and I'm going to go back to my samples folder, which will take a second to do. Okay. So here we have a demo structure, organic. All right. And uploading this structure file, analyze it, uses its knowledge bases to find the correct functional groups. And so as you can see here, alcohol, alkyne, aromatic, and an ether. And what you can do is overlay all four, and you can have a general idea of where your peaks should be if you're identifying or characterizing an unknown. And so let's go back and try with a spectrum. So let's do an unknown spectrum. So I'm going to go to my samples and try an unknown here. Okay. So here you use the find peak option to suggest a peak, and you can correlate it. Go to the next one. Ah, perfect. So this one looks like a pretty good match. And so I'll add it to my summary. And then these ones, let's see. That one's not too bad. But we can move down and see what else there is. A lot of these peaks don't align, so this one does look pretty good though, so I will add it and move to the next one. It's about the same spot, so I'll just keep moving. You can also select a peak if you like. These ones don't really seem aligned. And I'll keep moving. This one looks pretty good, so I'll add it to the summary as well. And I will do one more. These ones are all, I already added some of these. So I will go back to my summary now and see what I've added. Alkynes and two different kinds of alkanes. So this is what it should look like overlaid. And it looks pretty good for the most part. Some questions here. But in case I want to test it out, I can do transfer to, and I'll put it into search it, replace. And I don't need a computed spectrum for this one. And I'll search then. And we get a hit for 3,3-dimethyl 1-butene, which is pretty much what I said it was in the analyze it. Nice. Okay. One other interesting tool is I go to view and we have a Sadler handbook. It has a little pop-out window like this. And so for alkynes, you can get a lot of different information and some notes about where it should appear and some information that is very specific to this classification. Sorry, this functional group, which is pretty nice. Okay, and so now we'll move to IR polymer option. So I will go to polymer IR and I will open. I'll go back to analyze it, and we'll do a mixture of polymers. All right, so we'll do the same process here. Okay, so that one looks pretty good. We'll do another suggest. All right. Let's look at some options here. Some of these peaks aren't really aligned around 1200. Don't like these ones either. That one looks pretty good, so I'll add it to my summary as well. It's the same kind of process. And then from here, I can do the same thing, and I can see that there are two different kinds of polymers in this mixture at least. It looks pretty solid. A lot of the peaks do align. Actually, I would say most of them. And most of the peaks are cover forward except for this one. So it's pretty good. So say I wanted to put this into a report. So I can hit the transfer to bar again and put it into report it. And I see that I haven't set up any templates, but we have some. So if I would like to define one, it's quite an easy process. So here, I'll go to add. And actually, say I was in the samples folder, which it should have been. I would go back out of samples, and then here we have report templates, and specifically have one for Polymer IR, which is nice. And so I'll open that, and I'll add it. And then from here, I'll close, because now it's added as a default template. And so I'll go back to report it, and it sets it up nicely for me. Those were the three examples for the three alternate methods to identifying a spectrum. That's the end of the demo. And thank you for listening to my presentation. We can now jump into the Q&A.
That was a great webinar, Calvin. We've reached the end of our presentation today. Thank you, Calvin, for your time and expertise to present us your talk on the latest advances in spectral identification, SmartSpectra, classification models, and more. We'd now like to open up the session to some questions from our attendees, which if you can please type in using the questions toolbar, that would be great. If we don't get to your questions during the webinar today, don't worry, we'll follow up via email. So let's see what we have here. All right. How about, let's see what we have. My apologies. How can you set up searches in KnowItAll to always include certain compounds in the hits? For example, I have an IR spectrum that I know contains cellulose and calcium carbonate, but may also contain one or more other compounds.
In this case, one way to do it is create. You can create a hit list that always have those compounds. That's option one. Option two is you create your own databases, and then option three, you keep those files. Option three is useful when you have a mixture. You always have those compounds in your mixture. You want to find the unknown component in your mixture. Then in this case, you should keep files and then add into the I think there's an option when you do mixture analysis as in must exist component. So that way you can carry on your search just for unknown portion.
Great, and thank you too. Forgot to mention, we're also joined by Dr. Michelle D'Souza, who's one of our product managers for Wiley Science Solutions as well. So thank you, Michelle. How about this? Let's see. Where did you source the actual structures from?
I can answer that. So the data is actually from our collective data collection across all techniques. We ensured that the SmartSpectra records do not replicate empirical data that already existed, so these should all be new.
Excellent, thank you. Here's one. I already have the KnowItAll IR and Raman spectral library. How much more coverage do I get by adding SmartSpectra?
Our spectral library has like 300,000 spectra for the empirical data, but it doesn't have the type of compound covered by the SmartSpectra. We purposely, when we create a SmartSpectra collection, we purposely use compounds that is not in our IR and Raman databases. I mean, Calvin, you can elaborate on that, but
yeah, sure. So it just doubles the amount of spectra that we have, and it's about 400,000 for IR and 33,000 for Raman. And that we also have something called a Smart Bundle, which is a package that combines both empirical and SmartSpectra collections. And this would be our broadest compound coverage package, I guess is something that I would mention.
Great, thank you both. How about this one? What are the typical wavelength, wave number range entries in the database? It looks like minimum wavelength is around 2.5 Similarly, how does the database handle unknown spectra of mixtures?
Yeah, this is a good question. You're right. The regular IR range is up to 4,000 cm, but KnowItAll database itself is a continuous wavelength in x-axis. So your spectrum, there's no limit. What is your beginning x and ending x for your spectrum? It's just our reference spectrum may have a range, but you don't. In a mixture analysis, when your spectrum is out of range of a reference spectrum, we just do not use that portion to perform mixture analysis. So we use the known region that makes sense to the reference data to do mixture analysis.
Thank you, Michelle. I think we have some time for maybe one or two more. How about this one? If I perform a batch classification on all the spectra in a database that I built, can I then save my classifications in that database?
I'll take this one. Yeah, so once you perform a batch classification, a field will be added and the classifications will be output to it. Then you can save the database with the classifications included if you wish. It's pretty versatile that way.
Great, thank you, Calvin. Let's see. Is the summary feature in Analyze It new?
No, it's been there for a long time. It's been there for a long time. It's always in our training, so please use it.
And just to follow up on that, I think the same person asked about the Sadler info. I think that's also there, and that's been there for a while. Yeah, but our training does go over it. So if anyone has any questions about using KnowItAll, we have great training docs on our website.
Great point, Calvin. Thank you. I think we can maybe sneak one more in here. Let's see. How can KnowItAll classification models be applied to real world cases or real life cases?
So a great way to use these as an example that's real world would be the case of designer drugs. One of the reasons we started with the drug classifications is that it's an area where compounds are continually being synthesized. And since drugs are being synthesized at such a rapid rate, it makes it very difficult for forensics labs to keep up. I think we got some information about this from some of our some people we work with in the Appalachians. And since and models can help this as another tool in their arsenal of tools, and it'll kind of speed up their process. So you could also use the models to do a first pass quickly and also categorize the sample. And you could even think about adding an SDK to automate the process even further. It's kind of more about speed than anything else.
Great. Thank you, Calvin. Well, I think we've reached the end of our time today for questions. I'd like to thank our editor, Calvin Stevenson, and Dr. Michelle D'Souza of both of Wiley Science Solutions for taking the time to present us our talk on latest advances in spectral identification, SmartSpectra, classification models, and more. Questions that were not addressed will be answered by email. This presentation will eventually be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section. Thank you all very much for attending, and please enjoy the rest of your day.